Okay, in 6.1 we are looking at parabolas. Quick definition here, a parabola is the set of all points in a plane that are the same distance from a fixed line, which we will be talking about what that fixed line is called in a very short bit, and a fixed point, which also has a particular name for it. And so if you're looking at that fixed line and that fixed point and identifying every single point around these two settings that are the same distance from both, that's what constructs a parabola, constructs that U shape that we are familiar with. And then the points do have to be not on the line, for the record. The fixed point is called the focus. So that fixed point that we were talking about is the focus, and the fixed line is called the directrix, which are two things we're going to be finding here as we get into graphing, into looking at what this kind of conceptually entails. So those two words we want to make sure we're keeping in mind. Like, what is it that we're actually finding when I ask you to find the focus? What is it that we're actually finding when I ask you to find the directrix? We're finding those two settings by which every other point on our graph actually comes into existence. Because these two settings here, the focus and the directrix, the equidistant from those two things is what generates our points. Okay? And then we've got the distance between the vertex and the focus is the focal length of the parabola, which again is going to come into play. Okay, so some key concepts here about parabolas. We've got vertical parabolas and we've got horizontal parabolas. Vertical parabolas are the ones you've been working with, I'd say, a little bit more frequently, a little bit more comfortably over the last year and a half or so. The vertical parabola's equation in descriptive form is y minus k equals 1 over 4c x minus h quantity squared, which is what you've seen before. Now granted, I do believe 1 over 4c has always been referred to as a, so this piece here might look slightly new to you, but this is still that quadratic form that you've seen over and over and over again. 1 over 4c, you're going to see this a bit written into our notes, 1 over 4c equals a, because it's kind of taking a's place here. Excuse me. And we've got our vertex. The vertex is that same idea that we looked back at in Unit 1 when we looked at graphing quadratics and linears and exponentials and absolute values, that the h is what zeroes out the x component of our equation, the k is what zeroes out the y component. You've got your focus and your directrix, which are going to be a point and a line, as we talked about up above, and we highlighted them up above, that are a distance c in either direction away from your vertex. The focus is always inside the parabola, inside parabola, and the directrix is opposite the focus. And then you've got your focal chord length, which is your 4c. Okay? In a horizontal parabola, everything looks very similar. Oops, forgot a parenthesis, sorry. Horizontal parabola, everything looks very similar, except the x's and y's have switched places within the equation. Our y now is inside of the squared rather than the x, but everything still operates very similarly. Vertex is still hk, h being whatever zeroes out the x component, which is now going to be over here on the left, and k being whatever zeroes out the y component. You'll still have a c, which will be the distance to and from the vertex to the focus and the directrix, and so you'll see that kind of at play still. And then one final thing we want to keep in mind is generally speaking the shape, and so we have two pictures here, so you can see what we're talking about here. So that focus inside of the parabola, you can see again the focus inside of the parabola, the directrix is always opposite the focus, so if the focus went right, the directrix goes left. If the focus goes left, the directrix goes right. Similarly here, the focus went up, so the directrix went down. Right, it's down here, below the parabola. If the focus went down, then the directrix would go up. It's always opposite the focus. Okay? We also have what's called a line of symmetry. We've looked at that a little bit. but it's going to go kind of straight through that quadratic, allowing us to reflect on either side of our parabola. And then one thing we want to continue to keep in mind is something you were introduced to in Honors Math 2, which is what gives the parabola its direction. So we would be going upwards here. If our A, or now we're going to be calling it 1 over 4c, but if our A is positive, that causes my parabola to go up. And then conversely, if my A is negative, that causes my parabola to go down. It's a similar thought process with the horizontal. If my A is positive on a horizontal, that causes my parabola to go right, because right is the positive direction for the x's, just like up is positive direction for the y's. And if my parabola went left, that's what it would make, or that would mean that my A, or again my 1 over 4c, is negative. So we want to keep that in mind as well as we get into graphing here, because we want to make sure that as we find our different elements, that the general picture that we are constructing on our paper actually makes sense with kind of what we mentally know it should look like. So you want to think about that ahead of time. Okay, so these first two are going to allow us just to kind of get back into graphing parabolas without any of the stress of the new stuff, of a focus or a directrix or anything like that, but just reminding ourselves, how do we find our vertex? How do we sketch it? Where's our line of symmetry? That kind of thing. Okay? So here we go. I'm going to do number 1. I would recommend then pausing the video, giving number 2 a shot, and restarting it when you're ready. That way you get a gauge, like, how am I doing with this so far? Knowing that after number 2 we are going to be building in the rest of this material, as well as doing a little completing the square review. So here we go. In this first one, I first need to get it in its descriptive form, which means subtracting this 3 over to the other side. We have x minus 3 equals negative 2 times y plus 1 quantity squared. Okay. This allows me to now pull out my vertex, my hk. My h, again, is whatever zeroes out the x, and so in this case that would be positive 3. My k, whatever zeroes out the y, which in this case would be negative 1. And so I know that's where I'm starting. That's my vertex here. 3, negative 1. Okay, the other thing I want to kind of keep in mind as I now go about the rest of my sketch is which way this graph should go. Because I am x equals with a y squared, I know I'm a horizontal parabola. And because this is negative, a negative horizontal parabola tells me my parabola is going to be going left, and so I kind of know I'm going to be ending up over here. And that's going to help me pick what numbers to now plug in. And I can plug in x's or y's. I myself usually plug in y's. In this kind of setup, because the y is going to be squared and I can just solve for x pretty quickly at that point, but it is your choice. But so say I plugged in y equals 0. Okay, when y is 0, this would be 0 plus 1, 1 squared, which is 1 times negative 2, negative 2. Adding the 3 over, I get x would be 1. And so I know when y is 0, my x is 1. And I could plot that point. Now the nice thing about a parabola is because of that line of symmetry, I actually already know that I could reflect this across my vertex here, or across my line of symmetry, and I actually know my other point's going to be here. Now if you weren't comfortable doing that, you could also plug in y equals negative 2, because that's what would be down here, right? Y equals negative 2. And then y is negative 2, we'd have negative 2 plus 1, which is negative 1 squared, 1. Times negative 2, negative 2. Adding the 3 over, we get 1. And sure enough, my point is at 1, negative 2, which confirms that reflection idea. Okay, and then that's all I need for my parabola. Okay, my line of symmetry in this particular case would be right here. And we're going to actually write out these equations in the next one. This is a horizontal line, so this would be a y equals equation. So if you wanted to write it now, you could. Line of symmetry would be y equals, and this would be negative 1 in this particular case. If it was a vertical line, then it would be x equals. Okay. Okay, so my recommendation, go ahead and pause the video, give the next one a shot, restart it either when you are stuck or you have an answer, whichever the case may be, before we throw in the rest of our parabola material. Okay, so here we go. It's already in descriptive form, so I'm good to pull out my HK. My H in this case, whatever zeroes out the X would be 2. My K would be 0. In this case, we are y equals with an x squared, which tells me I'm a vertical parabola. And then because I have a positive a, or a positive 1 over 4c, then I know that this vertical parabola is going to be facing upwards. And so again, that could potentially help me make sure that I plug in points that will actually generate answers. Okay. In this case, because the x is being squared, I'm going to plug x's in. So I'm going to start with x equals 2. Okay. When I plug in x equals 2, I get 2 minus 2. I'm sorry, x equals 2 would not be helpful. That's my vertex. I'm going to plug in x equals 1. Okay, when I plug in 1, I get 1 minus 2, which is negative 1. Squared is 1. Times 2/3 is 2/3. If you plug in 3, you'll get the same value. You also could take a moment and plug in 0 or 4 if you wanted to. Plugging in 4, you would get 8/3, which would be 2 and 2/3, which would put you somewhere up here. You get the same value if you plugged in 0. And you get your parabola here. Okay, line of symmetry would be here. This is a vertical line, so this would be an x equals. And in this case, that would be x equals 2. Okay, so let's go ahead and throw in some of our other pieces now. And then we're going to do a little difference of squares review and then practice it all together. Same thing, there are going to be 2 of each. My recommendation, I'm going to do 1, pause the video, give the next one a shot on your own. Okay, so here we go. We're now going to find everything. We've got a list of steps over here to help us out if we'd like to use them. Okay. Step 1, I do need to put this in descriptive form, meaning add the 2 over. This is going to allow me to pull out my HK, my vertex. My H is whatever zeroes out the X, which would be negative 2. My K, whatever zeroes out the Y, which would be positive 1. This there. It's good to always have that kind of general shape in mind. In this case, we are a y squared, so we know we're horizontal. A positive y squared, so we know we're going to the right. And so again, that could help me plug in points because I know I'm going to be facing this general direction. Okay. So then plugging in other values. When x equals negative 1, actually, I'm going to plug in y equals. When y equals 2, I'm going to plug 2 in. 2 minus 1 is 1. Squared is 1. Times 1/2 is 1/2. Minus 2, subtracting that 2 over, would be negative 1/2. So when y equals 2, x equals negative 1/2. Which is the same thing you will get when you plug in y equals 0, is negative 1/2. And then maybe you plug in y equals 3 as well if you wanted. 3 minus 1 would be 2, squared is 4, half of 4 is 2, minus 2 is 0. So when we plug in y equals 3, x is 0. Same thing when you plug in y equals negative 1, because of that reflection element. We can reflect it over to the other side. And then if you really wanted to do one more, you could. When y is 4, 4 minus 1 is 3, squared is 9, half of that is 4.5, minus 2 is 2.5. And so we can actually give ourselves a pretty good little structure here of what our graph looks like. Just to guide our sketch. Okay, so there's our parabola. Excuse me, sorry. Okay, solving for c. So a equals 1 over 4c. We talked about that at the beginning, right? You've always called it a, but we're now going to call it 1 over 4c. So my 1/2 here, my a, is 1 over 4c. The reason we want to find this is because we are now going to find our c. Our c is what gives our distance to our focus and our directrix. So we need to solve for this. People solve these all kinds of ways. I'd say a lot of people like doing a kind of a cross multiplication element here. So 1 times 4c is 4c, 2 times 1 is 2, and then dividing the 4 you get 1/2. Excuse me, sorry. And so that 1/2 tells us how far from my vertex my focus is going to be, how far from my vertex my directrix is going to be. Okay? Remembering from our picture earlier here, our focus is always inside of the parabola. Focus is inside of the parabola. And so in this case, I'm going to be going 1/2 from my vertex inside of my parabola. And so my focus is going to be right here. My directrix is always opposite of my focus. So since my focus went that way, my directrix is going to go 1/2 this way. And the directrix is a line. And so in this case, my focus here is at x equals -1.5 and my y of 1. My directrix is a vertical line, so this is an x equals -1, 2.5. -2.5. And my line of symmetry, which we started writing on the first 2 problems, but now we are officially going to make sure is written, is y equals, because it's a horizontal line, and this would be y equals 1. Okay? And that's graphing a parabola. Okay, so my recommendation, pause the video, give number 4 a shot, restart it either when you're stuck or you are ready. Okay, here we go. Turning it into descriptive form means subtracting that 3 over. Y minus 3 equals -2 times x plus 2 quantity squared. Okay. Pulling out your vertex, your h in this case would be -2, your k would be +3. And then again, always think about what direction you know you'd be headed. This is an x squared, so we know we're a vertical. A y equals x squared, so we know we're vertical. A negative a, or a -1 over 4c, tells me I'm going down. So I want to see that as I'm now graphing. Okay, if I plugged in x equals -1, I get -1 plus 2, which is 1 squared, times -2 is -2, plus 3 would be 1. So when x is -1, my y is 1. And with that, we've got our sketch. Okay. Okay, finding your c then. So in this case, -2, which is my a, is equal to 1 over 4c. If I cross multiplied, I'd get -8c equals 1. Dividing the -8 would be c equals -1/8. And so I know I'm moving 1/8 to my focus and my directrix. Okay? Focus, remember, is always inside the parabola. So we're going 1/8 into the parabola, meaning in this case, we are going 1/8 down. Okay? The directrix is always opposite the focus, so in this case, that would be 1/8 up. And we've got our directrix here. Okay? Our focus then, this coordinate point, is at x equals -2, y equals 2 and 7/8, right, which is 23/8. or you could do 1/8 less than 3. And then the directrix is a horizontal line, so this is y equals, and it's 1, 2, 3, and 1/8. So this would be 25/8. My line of symmetry, which would be right here, is a vertical line, which tells me it's an x equals, and in this case, it's an x equals -2. Okay? Okay, before we do 2 more practice ones, we do need to really quickly review completing the squares. Completing the square is something you would have been introduced to last year. So I've grouped these in pairs so that I can do one and then you could practice one in increasing difficulty. If this is something that a little bit of a struggle for you, rest assured that this is going to be some extra practice is going to be in every single lesson because we do need to be able to complete the square for each of our conics. So we are going to continue to be looking at this. But you also could always come in and work with me in office hours or email me or whatever the case may be, or there's a ton of other tutorial videos out there on completing the square. Okay, so I'm going to do this one first. Okay, completing the square, the first thing you want to do is get everything that isn't part of the squared variable to the other side of the equals. So in this case, the x is what's being squared, so anything that's not an x, I'm going to get it to the other side. The y is already over there. I'm going to move this 4 over. Maybe y plus 4 equals x squared plus 6x. Excuse me, I'm sorry. Okay, so for completing the square, you always look at your middle term here, because we're going to be putting something back here so we can factor. You look at your middle term here, and you ask yourself, what's half of that? That'd be 3. And then what is that number, in this case 3, squared? Well, 3 squared would be 9. And so I'm going to add 9 to back there. The reason we are adding 9 is to take a moment and think, if you were to factor this, what would this factor to? And hopefully you identified that this would factor to x plus 3, x plus 3, or x plus 3 quantity squared. The reason we are doing this completing squares to get that idea of x plus 3 quantity squared. Okay, but in adding 9 over here, I've now fundamentally changed my equation. If you think of this as like a scale, this side is now 9 heavier than this side is. They aren't equal anymore. And so if I'm going to add 9 to this side, I also have to add 9 to this side. Because now I've maintained the equality, right? They're both equally weighted. And so now I can finish out the problem. This is y plus 13 equals, and factoring this, x plus 3 quantity squared. Okay? Okay, I want you doing this one next. So go ahead and pause the video, give this one a shot, restart it when you're ready. Okay, getting rid of anything that's not part of the squared variables. In this case, that's subtracting that 1. Okay, you ask yourself, well, what's half of -8? -4. Squared, positive 16. But since I've added 16 to one side, I have to add it to the other as well. And so now we get x plus 15 equals, and this factors to y minus 4 quantity squared. Okay, next one's for me. Because now we're going to up the difficulty a little bit. Okay, reminding ourselves, what do we do when there's a leading coefficient? So, still have to get rid of all the all the terms that don't have the squared variable bit. So in this case, x is what's being squared, so I want my x's to stay together, but I'd like to get rid of that plus 3. And so I'm going to send it over here. Y minus 3 equals 2x squared minus 12x. Okay? When there's a leading coefficient, you do have to factor that. Well, you don't have to, but I'd say I'm going to demonstrate it factoring it. So this would be x squared minus 6x. What that means, though, is that you have to be careful about what you're adding in. Okay, in factoring this 2 out, what we're now putting in here has to be modified slightly when we put it on this side because of this fact. Ready? Half of negative 6, negative 3, squared, positive 9. But in putting that 9 there, I haven't actually added 9. This entire quantity is being multiplied by 2. I've actually added 18, right? Because this is 2x squared minus 12x plus 18, if I were to distribute that 2 in. So I'm not going to add 9 over here. I'm going to add 18. You have to remember to multiply the leading coefficient to your added term when you add in on the left. Okay? And then this finishes out exactly the same. Y plus 15 equals 2 times this factor's 2x minus 3 quantity squared. Okay, I want you to try the one below it. So pause the video, restart it when you're ready. Okay, so here we go. Adding the 8 over. Factoring out the 4. Oh, I'm so sorry. I forgot to say, this was supposed to be a 16. If you need to now pause the video and go ahead and redo it with the 16, that's my bad. I'm sorry, that was supposed to be a 16, and I was supposed to say that before I had you pause the video. Okay, so go ahead and pause the video, change that to a 16, restart it when you're ready. Okay, factoring the 4 out, this would be y squared plus 4y. Excuse me. Half of this, 2, squared would be 4. But again, I haven't added a 4, I've added a 16. And so this is x plus 24 equals 4 times y plus 2 quantity squared. Okay, dialing it up one more notch before we go back to our parabolas and use this within the context of our parabolas. Okay, what happens when our leading coefficient is a fraction? Okay, so I'm going to add this 6 over. Factoring out the 1/2. Now carefully or really quickly, when you're factoring out the 1/2, what does that make that 4y? It doesn't make it 2y. Right? When you are factoring, like when I factored out this 2 here, and the 12 became a 6, what are we actually doing when we're pulling the 2 out and making the 12 become a 6? You're dividing, right? Dividing by a fraction is the same thing as what? Dividing by a fraction is the same thing as multiplying by its reciprocal. So when we factor out the 1/2, when we divide 4 by 1/2, we're actually multiplying 4 by 2. And so this is 8y. And you can always double check that by redistributing, right? 1/2 distributed back in would be 1/2 y squared, check. 1/2 times 8y, 4y, check. It's good to make sure you're really careful with fractions. Okay, half of negative 8 would be negative 4. Squared would be positive 16. But then I haven't actually added 16, I've added 1/2 times 16, which is 8. And so that gives me my final answer. And so this is the last piece of the puzzle here with our difference of squared. I'm sorry, I keep saying difference of squares. Last piece of our puzzle with completing the squared is remembering that when you divide by a fraction, it's the same thing as multiplying by the reciprocal. Okay, so I want you to try this last one. Pause the video, restart it when you're ready. Okay, adding the 1 over, we have y plus 1 equals, and actually I'm going to leave a little bit of space there. Factoring out the 1/3, we would have x squared plus 18x. Okay, Half of 18, 9. Squared, 81. Haven't actually added 81 in though, I've added 27. And so that gives me my final answer. Okay, so back to parabolas for 2 more problems, and then that's 6.1. Because we actually aren't going to be doing writing the equations today. So we're just going to focus on graphing here. Okay, so number 5 together. Number 6 you'll pause and do that one on your own. Okay. First things first, we need to get it into descriptive form. Well, in this case, that means we've also got to do complete the square. Okay, so I'm going to start with subtracting the 5 over. I don't have a leading coefficient to factor out, so I'll just write it. Half of negative 6 is negative 3. Squared is 9. Adding 9 to one side, though, means I have to add it to the other. And so we've got our initial equation. Okay. Pulling out my HK then. My H in this case would be negative 4. My K would be positive 3. And again, it's good to always keep in mind what's the shape of this going to be. This is an x equals y squared, so we know we're a horizontal. It's a positive a, or a positive 1 over 4c out front here. And so I know I'm going right. So I'm going to be over here with my parabola. Okay. Plugging in other values. What happens when y is 2? Well, when y is 2, we'd have 2 minus 3, which is negative 1, squared 1. Minus 4 is negative 3. So we'd be right here. Same for when y is 4. You also could plug in y is 5 and y is 1 if you wanted to. That would generate 0 in both of those cases. And again, you could keep going further than that if you wanted to, although we've got a nice general shape for our parabola at this point. And so I'm going to go ahead and call it there. Okay. So for your C, my A in this case is 1, which is my 1 over 4C. Cross multiplying, we have 4C equals 1, which means C equals 1/4. So for my focus and my directrix, I'm going 1/4 from my vertex. Focus, one more time, is always inside the parabola. So in this case, I'm going 1/4 in this direction. So there's my focus. Directrix is always opposite the focus. So we're going to go there, and it is a line. Okay. So the focus here is at x equals negative 1, 2, 3, and 3/4, or 0.75 if you prefer to think of it as a decimal. And then my y is 3. My directrix is at x equals, because it's a vertical line, negative 1, 2, 3, 4, and 1/4. So negative 4.25. Whoops, forgot the negative. Negative 4.25. And then your line of symmetry goes right down the middle. Horizontal line, so it's a y equals. In this case, this would be y equals 3. And there's your parabola. Okay, last one's yours. Pause the video, give number 6 a shot, and restart it when you're ready. Okay. Descriptive form, subtracting the 7 over. I do have a leading coefficient to factor out in this one, so this would be 1/2 x squared minus 4x. Half of negative 4 would be negative 2. Squared is positive 4. I've added a 2 to this side, so I have to add 2 to the other. And so we're at y minus 5 equals 1/2 x minus 2 quantity squared. Okay, my h in this case is positive 2, k is positive 5. And then I'm going to scale this. I'm going to count by 2's. Okay, so 2, 5. When I plug in, say, x equals 0, I plug in x equals 0, I get 0 minus 2, which is negative 2. Squared is 4, times 1/2 is 2, plus 5 is 7. So that would put me out here. Same thing for when you plug in x equals 4. You also could plug in, say 1, and that would give you 5.5, or 3, and that would give you 5.5, which would put you kind of approximately speaking there, if you wanted to add a little bit more structure to your parabola here. Okay, your a in this case is 1/2, which equals your 1 over 4c. 1 times 4c is 4c, 1 times 2 is 2, so my c is 1/2. So my focus and directrix are 1/2 in either direction from my vertex. In this case, focus would be up, because I have to go inside the parabola, so it would be 1/2 up, which is here. Directrix would be 1/2 the other direction, so in this case that would be down. So here's my directrix. Focus is at x equals 2. Y is 5.5, so 5.5. My directrix is a horizontal line, so y equals, in this case it's 4.5. And line of symmetry is a vertical line, so we're talking x equals, and in this case it's x equals 2. And that's graphing parabolas.